Already we have seen that in that flash drum example, uh, we qualitatively analyzed the 24 possible combinations, out of which we selected only one combination. Qualitatively analyzed. The same can be quantitatively analyzed. That quantitative analysis is called the relative gain array. Relative gain array. By using relative gain array, we can find the quantitative interaction among the loops that we can find. For that, this is the process in which how many transfer functions are here? H11, H12, H21, H22. The first letter indicates the output. Second letter indicates the input. Already I told you. So this one H11 means it is change in Y1 for change in M1, provided M2 is constant. Provided, because M2 will affect Y1. While keeping M2 constant, if you find change in Y1 among change in M1, then you will get the transfer function H11. What is H21? H21 is change in Y2 for change in M1, keeping all other variables constant. What is H2? H12? H12 is change in Y1 for change in M2. What is H22? Change in Y2 for change in M2. That is called relative gain array. The relative gain array for this is, the relative gain array is lambda 11, lambda 12, lambda 21, lambda 22. The lambda 11, lambda 12, lambda 21, lambda 22 gives the quantitative interaction among the loops. Quantitative interaction among the loops. How to find lambda 11? Lambda 11 is ratio between two quantities. The first quantity is change in Y1 with respect to change in M1, keeping M2 constant. Keeping M2 constant. Another one is divided by change in Y1 for change in M1, same quantity, but keeping Y2 constant. Keeping Y2 constant. It means this is open loop, this is open loop, this is closed loop of loop 2, open loop of loop 2. If you consider keeping Y2 constant means we have to keep the second loop closed, then only we can keep Y2 constant. Otherwise, we cannot keep Y2 constant because M1 will deviate the Y2. M1 will deviate Y2. What is interaction meaning? Here, M2 constant means it is easy. You can keep M2 constant by putting in manual mode of the controller. If you put the controller in manual mode, that is open loop means M2 will be constant. M1 is, you are giving change in M1. For that, what is the change in Y1 you are recording? The ratio between Y1 and M1 is numerator by keeping M2 constant. That you can do easily by keeping the second loop open. How to find the denominator? The denominator is again change in Y1 divided by change in M1, keeping Y2 constant. Here you notice that if we change M1, Y2 also will change because of interaction. But we want to keep Y2 constant means we should close this loop. Then only it is possible to keep Y2 constant. So here we are keeping Y2 constant. That's why there are two effects. One is because of M1, there will be direct effect. Another one is indirect effect. Both will be there on Y1. For that, we found the denominator. The ratio between the two is called lambda 1. The ratio between the two is called lambda 1. In the same way, you can find another three combinations. Let us see what is lambda 1, 2. Lambda 1, 2 equal to delta. First is already I told you output. Therefore, delta Y1 by delta M2, keeping M1 constant. What is not in there? Not involved. Input. Which input is not involved? M1. Therefore, keeping M1 constant divided by delta y1 by delta m2, keeping y2 constant, keeping y2 constant. That's all. Keeping y2 constant. That's all. What is the lambda 1 2 lambda 2 1? What is lambda 2 1 equal to? Change in y2 for change in m1, keeping m2 constant, divided by change in y2 for change in m1, keeping y1 constant. That's all. How to write this m2 and m1? The numerator, you have to keep input constant, which is not involved here. M2 is not involved here. You have to keep M2 constant. That's all. The denominator, you have to keep the output constant, which is not involved here, Y1. Y1 should be kept constant. That way you can remember all the 4 lambdas. Similarly, what is lambda 2 2? Lambda 2 2 is change in Y2 for change in M2, keeping M1 constant, input constant. What is the denominator? Change in y2 for change in m2, keeping y1 constant. That's all. So this way we can find all these 4 elements of relative gain array. In that relative gain array, if suppose you are getting the values like this, 0 1 1 0, here this corresponds to m1, this corresponds to m2, this is y1 y2. It means the 0 means m1 has no effect on y1, m2 has effect on y1. Here m1 has effect on y2 and m2 has no effect on y2. Therefore we can control y1 by m2 and y2 by m1. Suppose I'm getting a relative gain array like this, 1 0 0 1, like that I got, means 0 means no interaction, no interaction. M1 can be used to manipulate y1 and m2 can be used to manipulate y2. So this is the relative gain array. It means y1 can be used to manipulate, m1 can be used to manipulate y1, m2 can be used to manipulate y2. Another gain array is like this, 0.4, 0.6, 0.4, 0.4, 0.6. The property of relative gain array is, if you add the row, you will get 1. If you add the second row, you will get 1. If you add the column, then also you will get 1. If you add the column, you will get 1. So if you know one element, you can find all other elements. Suppose this is 0.6 means this must be 0.4. This is 0.4 means this is 0.6. This is 0.4. Like that, it can be easily found. But anyhow, what is the meaning? M1 has more impact on Y1. M2 has less impact on Y1. Similarly, M2 has better impact on Y2 and M1 has less impact on Y2. Therefore, M1 has to be used to control Y1 and M2 has to be used to control Y2. That way we can select. So how to find the relative gain array by using experiment, that we will see in this.